Energy and sustainability. Generative AI powering a greener future. The energy imperative meets AI innovation. The world's energy and sustainability sectors are under immense pressure to transform. Climate change urgency, the push for renewable energy, and the demand for efficient batteries, and the need to modernize aging oil and gas infrastructure all form a backdrop of critical industry challenges. Leaders are racing to hit aggressive targets: 100% clean power by 2035, widespread electric vehicle adoption, carbon neutrality pledges, and sustainable water management, to name a few. In this high-stakes context, AI has emerged as a strategic ally. By leveraging AI's capacity to analyze and create, energy companies are finding new ways to design solutions, optimize operations, and predict outcomes with unprecedented speed and accuracy. This highlights the urgency. Blackouts, climate events, competitive pressure, all of these things frame AI as a timely catalyst that can help reimagine how we produce, store, and use energy. The innovations needed to secure a sustainable energy future might very well be co-created with AI, from smarter grids to better batteries. Hi everyone, I'm Katie Trauth Taylor, CEO and co-founder of Narratize, and this is where you learn about all of the best practices using tech for new product innovation. I want to start by looking at the challenges and the barriers in the energy and sustainability sectors. Each sub-discipline or subsector within energy, oil, and gas faces distinct hurdles. Let's start with renewables, like wind and solar. These are now mainstream, but their intermittent nature and integration into the grid pose challenges. Grid operators can sometimes struggle to balance supply and demand when the sun isn't shining or the wind isn't blowing. Planning where to install renewable assets for maximum efficiency is complex, influenced by weather patterns and geographic constraints. There's also the urgent need for grid modernization. Many power grids were built for steady fossil fuel power, not the variable inputs of renewables. This requires advanced forecasting and control to prevent blackouts and make sure excess energy on a sunny day, for example, isn't wasted. Additionally, renewable energy companies face pressure to reduce costs and improve their performance. For instance, increasing solar panel efficiency or wind turbine output, so they can stay competitive with traditional energy companies. Innovation here often involves material science, engineering, data science, and so much more. Let's look at battery manufacturing. The world's transition to electric vehicles, or EVs, and renewable energy storage hinges on better batteries. Key challenges are improving energy density, charging speed, lifespan, and safety of batteries, while also cutting costs. Traditional research and development in battery chemistry can be painstakingly slow. Testing a new chemistry or electrode design in real cells and waiting through hundreds of charge cycles to gauge longevity can take months. Manufacturing all of this at scale introduces issues of consistency. Small changes in materials or processes can drastically affect performance or yield. There's also a hunt for new materials, like solid-state electrolytes or novel cathodes, to leapfrog current lithium technology. Supply chain and sustainability are concerns too. Reducing dependency on rare or conflict minerals like cobalt, and ensuring recycling or reuse of batteries to avoid environmental harm. Now let's look at oil and gas process engineering. The oil and gas industry, while so mature, is under pressure to become more efficient, safe, and cleaner. Challenges here include optimizing complex processes like refining, petrochemical production, or drilling ops, so that we can gain more output with less energy and lower emissions. The systems are often vast and intricate. A refinery has thousands of control points and potential failure modes. Ensuring safety by preventing spills, explosions, and leaks is paramount, and it requires constant monitoring. The workforce in this sector is also changing. A lot of expertise is in the minds of veteran engineers nearing retirement, so capturing that knowledge and making operations more automated is a priority. As the world gradually shifts away from fossil fuels, these companies face the strategic challenge of reinventing parts of their business, like reinvesting in carbon capture or hydrogen fuel, while still running core operations optimally. Now let's look at industrial water treatment. Water treatment plants for wastewater or industrial processes are crucial for sustainability. ensuring that water can be reused safely and the pollutants don't enter the environment. Challenges here revolve around operating efficiencies and compliance. Treatment processes are energy intensive for pumping, aeration, and more. So operators seek ways to reduce energy use while meeting strict water quality standards. The chemistry and biology in water treatment are dynamic. Loads of pollutants can change daily, making optimal dosing of chemicals or aeration quite tricky. Often these plants run on legacy control systems with manual adjustments by operators based on experience. But there's also increasing regulatory scrutiny on emerging contaminants like microplastics or pharmaceuticals in water, which current processes might not handle well. This all prompts the need for innovation. Water scarcity in many regions adds pressure to reuse and recycle water more efficiently, meaning treatment must not be only effective, but also cost efficient and scalable. To sum all of this up, the energy and sustainability industries are dealing with variability in supply or input, complexity of systems, high stakes for reliability and safety, and a mandate to innovate for cleaner, more efficient solutions. These barriers often result in an under-optimized operations, slower R&D cycles for new solutions, and difficulties in scaling sustainable practices. AI offers unique ways to address some of these issues by injecting advanced data-driven decision-making and creative problem-solving into the mix. So let's look at GenAI's role in powering solutions. AI is being applied across these sectors as a versatile tool, one that can design, predict, optimize in ways that significantly alleviate the challenges that we've talked about. So let's break down these contributions. Renewable energy. We see smarter grids and better planning. In renewables, GenAI is enabling real-time decision support and grid optimization. Researchers at NREL, the National Renewable Energy Lab, highlight that GenAI can provide proactive, real-time energy system operations support, essentially helping grid controllers anticipate and adjust for fluctuations. For example, AI models can forecast solar and wind output more accurately by analyzing weather data and historic patterns, then generate optimal strategies for balancing the grid, like suggesting when to store excess energy in batteries or schedule maintenance downtime. AI-driven control algorithms can preemptively reroute power or engage backup systems to maintain stability, increasing the grid's reliability and resilience. This is a game changer for preventing blackouts and for efficiently using every watt of renewable power that we can get. GenAI is also being used to improve renewable asset design and placement. Wind farm layouts benefit from AI that can simulate countless turbine placement configurations over varied terrain, generating arrangements that maximize total output and minimize wake interference between turbines. Similarly, AI can help design wind turbine blades or solar panel materials by analyzing performance data and sort of imagining new designs. Some researchers are using AI to propose blade shapes that capture more wind or panel coatings that reduce reflection. Furthermore, as utilities adopt distributed energy resources or DERs like rooftop solar and home batteries, AI assists in planning how to integrate them. It can generate models of distributed networks with high DER penetration and identify where to upgrade infrastructure or how to configure smart inverters to support the grid. According to industry analyses, utilities investing in advanced distribution management systems and AI expect to cut carbon emissions significantly. One projection is a 30% reduction in the long term by better integration of renewables and DERs. Generative AI in this context acts as the brain of a smart grid, constantly learning and recommending actions to keep the electrons flowing optimally and sustainably. Let's look at battery manufacturing, accelerating discovery and production. GenAI is having a profound impact on battery technology by dramatically speeding up both materials discovery and manufacturing optimization. On the R&D side, AI models like generative chemistry models can propose new battery materials such as cathode compounds or solid electrolytes, all of which meet desired criteria like higher voltage, faster ion transport, safer thermal profiles. Instead of experimentally trying hundreds of combinations, researchers can leverage AI to virtually screen millions of possibilities and pinpoint a handful of promising candidates to test further. A prime example of AI's potential was illustrated by DeepMind's material discovery, which included new crystal predictions useful for batteries. By finding stable materials that were previously unknown, AI opened paths to potentially double battery capacities or eliminate rare metals. Beyond materials, AI helps in designing the physical structure of actual batteries. So it can optimize electrode microstructures, like how particles are arranged, to balance energy and power. Or it can help design new battery architectures like novel cell shapes or cooling pathways. For manufacturing, AI can analyze production line data like coating thickness, drying times, formation cycling performance, and then generate improved process parameters so you can yield and perform more consistently. This is crucial for scaling up new chemistries. Often a lab battery performs well, but then mass producing it gets really tricky. And AI can suggest how to tweak the process to maintain quality, or even identify subtle designs and data that predict a batch won't meet specs, really enabling proactive adjustments. One particularly innovative use is in charging algorithm design. AI can generate charging profiles, aka sequences of current voltage pulses, that charge batteries faster without damaging them, by learning from degradation patterns. Some experimental work has shown AI-designed charging protocols that charge lithium-ion cells to 80% in a fraction of the time while minimizing heat buildup. If commercialized, this would address the consumer pain point of long EV charging times. All these contributions mean the battery industry can iterate faster. Instead of a decade to bring a new chemistry from lab to market, maybe it can be done in a few years or months with AI-guided experimentation. Manufacturing could see fewer failed batches and higher throughput, reducing costs. Ultimately, AI in batteries is about pushing the performance envelope and scaling up swiftly, which translates to longer range EVs, cheaper energy storage for the grid, and a more secure energy transition. Now let's talk oil and gas, optimizing complex systems and transitions. In the oil and gas sector, Gen AI is being used to optimize operations and aid in the transition to cleaner practices. One key application is in reservoir modeling and simulation. Traditionally, geologists and engineers build models of underground reservoirs to decide where to drill and how to manage pressure. Generative AI can now analyze seismic data, well logs, and production data to create much more accurate and nuanced reservoir models, effectively imagining the subterranean geology in 3D. These AI-generated models help in making more informed drilling decisions. They maximize extraction of oil and gas with fewer wells and lower risk of dry holes. They also assist in enhancing oil recovery strategies, like where to inject water or CO2 to push more oil out, thereby improving yield from existing fields without new exploration. Another area is process optimization in refineries and plants. Refineries have numerous units, crackers, distillers, reformers, with interdependent settings. Generative AI, using reinforcement learning or advanced optimization techniques, can suggest operating set points that increase output quality and quantity while reducing energy consumption. For instance, by analyzing historical plant data, the AI might find a slightly different temperature and pressure in a reactor yields the same output faster or with less energy. Some refiners have reported AI assisting to reduce energy usage by a notable percentage, which directly cuts costs and emissions. AI can also generate predictive maintenance schedules, foreseeing equipment failures before they happen by looking at sensor patterns. This preemptive approach avoids costly downtime or accidents, and it extends equipment life. Importantly, as oil and gas companies diversify and start investing more in renewables and carbon capture, AI helps bridge knowledge gaps. It can generate insights from vast troves of data to apply to new domains. For example, using fluid dynamics expertise from pipelines to design efficient carbon capture systems, with AI iterating in the design process. Safety and risk management benefit too. Gen AI can simulate worst-case scenarios, like a plant upset or a cyber attack on infrastructure, to test and strengthen response plans. As one industry leader put it to me, Gen AI is not just an innovation, it's a transformative force to enhance safety measures. Simplifying hazard recognition and streamlining safety planning are some of the key benefits. So in total, AI is helping oil and gas operate better, smarter, and faster. It squeezes more value from current assets, which has sustainability benefits by reducing waste and flaring, And it accelerates the integration of new, cleaner tech by leveraging the deep well of existing data and expertise in new and novel ways. This is an industry known for engineering prowess, and now adding AI-driven creativity to the toolkit helps us navigate a changing energy landscape. Now let's look at industrial water treatment towards autonomous, efficient plants. Water treatment is seeing the rise of AI-driven automation, and Gen AI is at the forefront of making treatment plants more adaptive and efficient. Let me share a success story that I get really excited about. This one's about how AI optimized aeration processes. This is typically the most energy-intensive part of wastewater treatment. In Cuxhaven, Germany, a treatment plant used an AI-optimized system that analyzed sensor data and predicted optimal aerator settings, cutting energy use by 30%. This is huge, considering aeration can be over half of a plant's energy bill. Gen AI goes further by continuously adjusting and learning from this data. It can suggest, for example, altering the aeration pattern dynamically throughout the day as load changes, always keeping oxygen at just the right level for the microbes to do their job without wasting power. Similarly, AI can optimize chemical dosing for disinfection or coagulation by generating dosing strategies that respond to real-time water quality data and then ensuring compliance while minimizing chemical use. Another role of AI is handling scenarios that plants weren't originally designed for. Here's an example. With emerging contaminants, an AI might propose new treatment steps or configurations. So suppose a plant finds a level of a certain pharmaceutical in its incoming water. AI can simulate and suggest if adding an ozone treatment or tweaking the biological process would remove it, potentially designing a retrofit process virtually. AI is also aiding predictive maintenance and asset management in water infrastructure. By analyzing vibrations, motor currents, and other sensor outputs, AI can generate predictions of pump or valve failures. This means maintenance can be scheduled just in time, avoiding catastrophic failures that might cause untreated water discharge. We're also seeing AI used to create digital twins of whole water treatment facilities, virtual replicas that can be used to run scenarios. Operators can ask the AI twin, what if incoming water flow increases by 20% due to a storm? And the AI can simulate and suggest how to adjust operations in advance, like open another treatment line or adjust clarifier settings. All of these improvements lead toward the vision of a more autonomous water treatment plant, one that self-optimizes for energy and performance and alerts humans when needed. This is so valuable as skilled operators retire and as utilities try to cut costs. From a sustainability perspective, the reduced energy use, 30% reduction in one case that I'll link in the notes below, and some plants even see up to a 50% for specific processes. This means a smaller carbon footprint for water treatment and optimized processes, all of which means cleaner water outputs, protecting ecosystems. In essence, Gen AI helps take the industrial water sector into the digital age, improving reliability and efficiency in a service that is often hidden but absolutely crucial to sustainable life. So now let's talk expert perspectives and future trends in energy and sustainability. Energy experts often describe Gen AI as a key enabling tech for the energy transition, the global shift to low carbon systems. According to McKinsey, companies innovating with Gen AI in energy could unlock hundreds of billions in value in coming years. One energy executive recently explained to me they're moving beyond pilot projects to, quote, increasing innovation approaches to adopting Gen AI, indicating that leaders are looking at AI not just for incremental gains, but to reimagine business models and opportunities. For instance, utilities might leverage AI to become energy service orchestrators rather than just energy suppliers, using AI to manage fleets of customer-sited batteries, EV chargers, and appliances in a way that benefits both the grid and consumers. A prominent trend experts point to me, is decentralization and digitalization. With more distributed generation, like rooftop solar, wind farms, batteries scattered about, the system becomes too complex to manage with traditional heuristics. AI is seen as the glue that will hold decentralized grids together by analyzing torrents of IoT data and orchestrating resources in real time. As one IDC projection mentioned, by 2026, about half of utilities will be investing heavily in advanced grid AI to handle DERs. Here's the long-term vision: AI helping reduce carbon emissions by enabling much higher renewable penetration. The 30% emissions reduction figure linked to better DER integration is an example of that potential impact. In oil and gas, expert dialogue often revolves around using AI to repurpose competencies. This industry has decades of experience handling big data, seismic, logs, and very complex operations. Now, applying AI could turn them into not just energy extractors, but also data-driven energy optimizers, and possibly leaders in carbon management. One future scenario is oil and gas companies using AI to become efficient carbon budgeters, optimizing how they use their emissions allowance among operations, and even using AI to advise other industries on efficiency, like leveraging what they learn internally. For the environment and sustainability sector, a trend in AI is climate risk and resilience. Gen AI can help model climate scenarios and design infrastructure from seawalls to flood management systems in an optimized way to handle those scenarios. City planners and energy companies are interested in AI that can generate optimal resilience strategies, such as where to microgrid enable communities and how to structure insurance for extreme events based on predictive modeling, all of which shows the broad applicability of generative AI in planning and sustainability challenges. On the policy and governance side, experts seem cautiously optimistic, but they warn of energy consumption of AI itself. Training large AI models is energy intensive. Ironically, one must ensure AI doesn't become the big carbon emitter. However, most see the net as positive if AI is used wisely, because the efficiencies and renewables it can unlock outweigh its own footprint. But we have to see adoption. The World Economic Forum has even debated whether AI will reduce emissions or increase demand. And the consensus is that, guided properly, AI can significantly reduce emissions by helping to optimize systems, though it requires conscious effort to use green computing for AI. I get really excited to meet other startup founders and companies that are dedicated to innovating in this space. It's truly remarkable, and I'll make a video on that in the future. Future trends include AI-designed energy systems from the ground up. We might see generative AI used to plan entire greenfield sustainable cities, where to place solar, how to lay out the grid, how to integrate water and waste systems, holistic designs that humans can implement. In sustainable fuel research like synthetic fuels and hydrogen, AI might discover catalysts or processes that make these fuels viable at scale. There is active research on AI in fusion energy design, for example, climate engineering, and other moonshot ideas too. Another expert perspective is the importance of training and trust. Energy companies are investing in training their engineers and analysts to work alongside AI, interpreting its suggestions and framing up the parameters of its training. Building trust in AI systems is crucial, especially in critical infrastructure, a point echoed by many surveys of very large companies, where people are still figuring out how to fully trust and integrate AI and build belief inside of the teams. Over time, as we see systems prove themselves though, and as explainability and transparency evolves, the trust will grow. So to sum it up, the expert outlook is that Gen AI will be integral to 21st century energy infrastructure, just as electricity was in the 20th century. It will serve as an intelligence layer that will enable flexibility, efficiency, and innovation at the pace needed to meet climate and sustainability goals. Those who lead in adopting these AI tools stand to not only reap cost and reliability benefits, but also position themselves as leaders in a transformed energy landscape. So let me share how our Narratize customers in the energy sector are driving faster innovation with Narratize. As Gen AI reshapes the energy and sustainability landscape with technical breakthroughs, it's equally important to drive organizational and industry change through clear communication and shared vision. Narratize plays a pivotal role here, serving as the product intelligence platform that helps teams co-author together inside of shared knowledge hubs all of the documentation that they need, from the seed of new ideas all the way through message market fit. Whether it's a renewable energy mid-market company or an AI-optimized grid solution, or a legacy oil and gas company looking to automate or augment aspects of its facility documentation, Narratize accelerates the creation of clear, accurate documentation, It captures real-time insights, stores them appropriately, and then generates outputs that trace to the source. This is transforming how feasibility studies, technical design documents, environmental impact assessments, regulatory filings, safety manuals, and strategic roadmaps get created. It's saving teams countless hours and keeping everyone on the same page to satisfy regulators, executives, and of course the innovation teams who make all of this work possible. For example, a utility company's innovation team can input the results of their AI-driven pilot project, like data on improved grid sustainability and customer savings, into Narratize, and it would output a crisp case study or white paper. The document would highlight the urgent trends like aging grid, renewables integration, and explain the AI solution, backing it up with data and articulating the company's future roadmap, bolstering its thought leadership and showing how it's innovating in that space. I personally love seeing our customers use these types of deliverables at industry conferences and policy-making discussions because it supports the story behind their good work. All of this is crucial for buy-in, from internal champions to boards and shareholders, and of course customers. Innovation storytelling will drive the future of adoption of AI inside of energy and oil. This isn't just a small gain. Innovators inside of energy and oil spend 20 to 30% of their week on documentation. Imagine being able to not just leverage AI technologies to actually analyze data and simulate new possibilities, but also to help you document your own insights along the way. In energy, this means engineers are saving hundreds of hours per year as they work to spend more time actually laying out grid scenarios and doing development. I want to share one more example, and this is of a cross-industry consortium on water initiatives. They use Narratize to create a comprehensive guide and action plan together. So instead of manually consolidating all of their different insights, data sources, and styles, they use Narratize to capture their insights together, harmonize the voice of the report, and produce a cohesive narrative. This human-in-the-loop approach means experts can iterate quickly, ensure accuracy, and reap the benefits of speed. Most importantly, Narratize is being used for massive knowledge retention and management across new product innovation cycles. It can maintain the single source of truth of documents, really a living, breathing knowledge base, using complex knowledge architectures that are unique to our platform. This helps teams integrate new insights, plug into existing databases, and keep continuously updated on the source of truth. In short, Narratize is supporting innovation in energy and sustainability, not by generating power or treating water, but by powering the narratives that drive these innovations forward. It ensures that complex transformations, like digitizing the grid or implementing AI in a refinery, are clearly articulated, understood by all stakeholders, and seen through to completion. By accelerating documentation and distilling real-time insights into shareable knowledge, Narratize helps break down silos between technical teams and leadership, as well as sales, marketing, and other go-to-market functions, fostering a new world of transparency with regulators and the public. It can help an organization accelerate thought leadership in the transition to a more sustainable future. In an industry where aligning multiple parties, from government, business, to community, is often as challenging as the technical work itself, having the right narratives can make all the difference. Narratize ensures those narratives are not only compelling, but also continuously fueled by the most accurate and latest data and expertise, truly embodying thought leadership in the age of generative AI-driven energy transformation. I hope that you're embracing these tools. I hope you continuously lean into the latest updates in AI for the energy and sustainability sector. Thank you so much for joining me today. I'm Trauth Taylor, CEO of Narratize. Until I see you in the next one, keep innovating.